Michael Mann, director of the Earth System Science Center at Penn State, joining us now to talk more about it. Thank you so much for joining us. You know, this one was remarkable because so many times we see these start in pretty rural areas and then work towards a few houses. But I mean, these folks were at a Chuck E. Cheese, so now we're in more of that urban suburban area.
Yeah, thanks. It's good to be with you. And this was a very unfortunate event, and it did start as a classic wildfire. But, you know, if you've spent time in Boulder or Denver in the winter, you know that you can get these very warm, very dry, severe downslope winds in the wintertime. And what we're dealing with is a winter that's been very warm and very dry already. So you take the sort of the preconditions that existed there, very dry, very warm, conditions that are favorable for wildfires. You take that event, those severe downslope winds that give you those very warm, dry conditions, and you have all that fuel, all of that dry wood material that's available to burn, and you get these massive wildfires. In this case, you know, Boulder, Denver, the cities, the urban sort of regions now abut all the way up to the lower parts of the slopes. So if you do get a wildfire going there, then unfortunately it can spread into those urban regions where there is lots more fuel when the conditions are, conditions are conducive to wildfires as they are.
And yet one image that will always kind of stick with me is the people in the parking lot. I think it was leaving a Costco, and you're surrounded by blacktop. There isn't a lot of fuel right there, and yet the median is burning or the top of the building catches. Can you speak to what has changed with how we think about these wildfires as they now move into these different environments?
Yeah, well, one question, of course, that we're asking are these, you know, when you have these very strong jet stream conditions, so when the jet stream is very strong, then you really have the potential for those severe downslope winds. And those winds help carry embers, right? They extend the range over which material, that has caught on fire can spread. And so even if you are in an area covered by blacktop, those embers can travel quite far when the winds are as strong as they were. And one of the questions that we're ultimately going to try to ask is, how unusual are these sorts of winds? Can we say that indeed climate change is increasing the occurrence of these very strong winds? I would also note that there was an event last summer that sort of in some sense also conveys this same problem where the wildfires in California, one of the wildfires actually crossed the Sierra Nevada range into Nevada. That's never happened before. And part of the reason that was possible were these strong winds that were able to blow those embers aloft. And so we are seeing these new atmospheric conditions that do seem to provide the raw material for these extensive, more destructive, more extensive, hotter burning, faster spreading wildfires.
Yeah, absolutely. A glimpse of what the study and what the science will work on next. Thank you so much for spending some time with us. That's Michael Mann, director of the Earth System Science Center at Penn State University.
Thank you.